Dear friends, good morning, and my dear students. Today I am going to explain you about how to write chemical formula of inorganic compounds. Inorganic compounds because there is presence of metals and non-metals, metallic ions and non-metallic ions. So we should keep in mind that there are two parts of inorganic formulas. First part is basic radicals. Second part is acid radical. Basic radicals are called cations and acid radicals are called anions. Basic radicals are also known as positively charged particles, whereas acid radicals are known as negatively charged particles. And we already know that basic radicals, that means cations, are formed by metals. That means metals are, most of them are cations and non-metals are anions. So, for writing the formula, we have to keep in mind the valencies also. So, some radicals have single valency and some have double or triple valency. So, where it is less valency, it is ending with ash as suffix. And where more valency is there, that is ending with ik as suffix. As cuprous, its valency is 1. Cupric, its valency is 2. In the same way, ferrous, its valency is 2. Ferric, its valency is 3. And more others are stannous, its valency is 2. Stannic, its valency is 4. So, these are the things we have to keep in mind. Again, some radicals are single atoms and some are double. That is called compound radicals. Single radicals are oxide, chloride, bromide, iodide, and sodium, copper, iron, tin, etc. But when we talk of compound radicals, in compound radicals, among basic radicals are ammonium, whose valence is 1 and its formula is NH4. But it is acting as a radical. It is acting as a cation. And in the case of acid radicals, compound radicals are nitrate, sulfate, hydroxide, bisulfate, bicarbonate, nitrate, etc. So when we are writing the formula, left side we have to write always basic radicals, that means which are positively charged particles, and right side we should write negatively charged particles, that is an ion, that is acid radicals. Suppose we have to write sodium chloride, then sodium left side, chloride right side. Sodium valency is 1, chloride valency is 1. Both the valencies are interchanged, and after writing then below the atom, suppose NaCl, here 1 is common to both. That's why 1 is not written. But when we are writing sodium hydroxide, in this case, sodium valency is 1, hydroxide valency is also 1. So here also 1 we are not writing. But if we are writing calcium hydroxide, then calcium valency is 2, hydroxide valency is 1. So this one we write below calcium, and calcium valence is 2 we write below hydroxide OH, and OH should always be written in the bracket, and then we write CaOH whole 2. We don't write without bracket. OH should always be written in the bracket. In the same way, calcium sulfate. Here we find calcium and sulfate. Both have two valencies. In this case, no need of writing SO4 in the bracket. But if I write sodium sulfate, then here we find that sodium valence is 1 but sulfate valence is 2. So that 2 will come below sodium, that is Na2SO4. But if you write calcium nitrate, then calcium valence is 2, nitrate valence is 1. Then in this case, NO3 should be written in bracket and then we should write CaNO3 whole 2. This 2 represents NO3. That means we have to keep in mind that when compound radicals are there and we have to write more than one, we have to keep that compound radical in bracket. Okay, if we are writing ammonium hydroxide, then we write NH4OH. Here, both the radicals have one valency. But if you write ammonium sulfate, here you find that sulfate has two valency, but ammonium has one valency. So NH4 should be written in the bracket and then we will write 2 and then SO4. That is NH4 whole 2 SO4 and that is called ammonium sulfate. Okay, in the same way, if we are writing ammonium chloride, here ammonium and chloride both have single valency. So we don't write 1 and we direct write NH4Cl. But if we are writing ammonium carbonate, then in this case, NH4 should be written in bracket and carbonate valence is 2. So that will come below ammonium. So NH4 whole 2 CO3 ammonium carbonate. In this way, we are writing inorganic formulas and please, if you like, subscribe and share. Thank you.